Hey guys, here we're going to start section 1.2 or topic 1.2. It seems like a pretty large section, so we'll probably have this video in multiple parts. Let's go ahead and jump into our first example under our notes. Step 2 is our notes, remember? And so let's go ahead and get going here. So our first example is not playing around. We have quite the equation to solve here. But if we follow a simple progression of steps and we just take it one step at a time, then it's really not too bad. So we really want to just make sure we take our time with this problem and just do, like I said, do one step at a time. Now, the whole purpose of algebra is to find out what x is. So x is basically a mystery number, and it's our goal to figure out what number it's supposed to be, right? So all this over here is equal to 32. So the question is like, well, what number would go here so that when I put all of this together, it would indeed equal 32? So our goal is to solve the puzzle, right? We want to figure out, well, what number is the x? X, it's kind of like a question mark, right? What number is it? All right, and so here's the process that I like to use when trying to solve a problem like this. It really goes down to the order of operations. So you guys have probably heard of the order of operations before, right? Pemdas. And typically, you follow the order of operations this way. You start with the parentheses, then you look for exponents, then you go with the multiplying and dividing, and then the adding and subtracting. But when we are trying to solve an equation like this, because we don't know what x is, we are undoing PEMDAS. Essentially, if PEMDAS is like, think of it like this. When you are getting dressed in the morning, you're putting your shoes on, you have to put your socks on first, and then you put your shoes on after it. But if you want to undo that process, you have to go in the reverse order, which is you'd have to take the shoe off first and then the socks, right? So what came last before, which was putting your shoe on, has to come off first, right? Take the shoe off first. So that's kind of how an equation works. Normally, when you're plugging numbers in, right, that's following the order forwards. But since we don't know what x is, we are trying to undo the equation. We are going to follow the order backwards, okay? So everything's going to kind of be reversing what's happening because we want to essentially, to figure out what x is, we have to reverse all of this stuff over here to try and get rid of it one at a time. So one thing that I like to do, let me go ahead and I will just rewrite this problem. Is I like to put a little line down where the equal sign is. And that separates the two sides of the equation. We have the left side, which has pretty much all this very interesting stuff. And then we have the right side, which currently is just the number 32. All right. So like I said, our goal is to try and get rid of everything on this side so that all that's left on that side is the x. So we want to get rid of this 2, this 4, this 3, this 8. We want to get rid of all of those things so that the x would be all by itself, and the last thing remaining. So in order to do that, we have to think, well, what are we going to cancel out first? What can we get rid of first? Should I be getting rid of this 2 first, this 3, this 4, or this 8? What should I try to get rid of first? Because you can't just do it in any order you want. You have to do it according to the order of operations backwards. So the first thing we're going to look for is anything that's being added or subtracted. The adding and subtracting kind of goes together. They kind of go hand in hand, so you can kind of tackle them both at the same time. Now, we have this minus 8, and so since that is a subtraction, we are going to tackle it first. So we look at this minus 8. seeing that it's a subtraction part of our order of operations, and we have to undo it. So we have to think of whatever the opposite of minus 8 is in order to cancel it out. So for most of us, the opposite of minus 8 is adding 8, right? If you opposite of subtracting is addition. So what we're going to do is I'll add 8. Let me use a different color here. I'm going to add 8 to the left side of the equal sign and to the right side of the equal sign. Remember, equals means balanced. So whatever's on the left side has to be balanced with whatever's on the right side. So if I add 8 to the left side, then I would also have to add 8 to the right side, just so everything remains in that balance. And so here's what happens. Here we have minus 8 plus 8. So if you take minus 8 plus 8, essentially you're canceling them out. That becomes a 0. So those are going to cancel out. And so now all that's left on the left side would be the 2x plus 4 in parentheses over 3. The minus 8 is no longer there because we've canceled out the minus 8. But now make sure you simplify the right side as well. 32 plus 8 is going to be 40. So when I add that 8 over here, I end up with 40. All right, so now we've gotten rid of one of the issues. We've gotten rid of that 8. So now I have to figure out what's next to get rid of. And a lot of you guys might think, well, if you're following the order of operations backwards, maybe we should do the adding part next. And then you would look at that plus 4 and think, oh, let's get rid of the plus 4. But there's a problem with that in the fact that the plus 4 is inside the parentheses. And we don't get to the parentheses until very, very last. So we won't do anything with that plus 4 simply because it's in the parentheses, and the parentheses part will come last. So what should we get rid of? Well, we got to think about the multiplying and dividing part. So when you look at the left side, the bottom of the fraction here means dividing by 3. Essentially, what we have is 2x plus 4 divided by 3. And so we want to undo division because that's next in line. So the opposite of dividing by 3, in order to cancel this 3 out, the opposite of dividing by 3 is multiplying by 3. So here's what I'm going to do. I'm going to multiply the left side of the equation by 3, and I'm going to multiply the right side of the equation by 3. Remember, anything that I do to the left side, I have to also do to the right side to keep things balanced. Now, a lot of you might think that, oh, this looks bad because I'm going to have to multiply 3 with all of this stuff. And that's not true. The only thing that happens when I multiply by 3 is this multiplying 3 that I've just done cancels out this dividing by 3, just like the 8 canceled out before, right? The minus 8, the plus 8, those are canceling each other out. So this 3 and this 3 are technically going to be canceling each other out because multiplying by 3 and dividing by 3 are opposites and therefore cancel out. So the 2 and the x plus 4 doesn't actually change. So in fact, that will still be here. The 2 and the x plus 4 will still be there. But now that 3 part will have gone away because the 3 at the bottom is gone. It's canceled out. But don't forget to simplify over here on the right. 40 times 3, we still have to multiply that by 3 because, the 8 over here doesn't cancel out. The 3 over here doesn't cancel out. We have to continue adding to this number. So 40 times 3 is 120. So this is going to equal 120. All right, so we still got some work to do. All right, but now you've noticed, look, we've gotten rid of the 3. Okay? So now it's just the 2 and the 4. So which comes first? Well, remember, the 4 is in the parentheses, and we can't do anything with that 4 while it's in those parentheses. So the next number we're going to target and try to cancel out is going to be the 2. So notice 2 right here is being multiplied with the parentheses x plus 4. So what that says, it says 2 times, and then the parentheses x plus 4. So 2 and x plus 4 are being multiplied together. Again, we are not actually multiplying them right now, but in the equation, that's what it says it's doing. So we see that we want to cancel out the 2. Remember, that's our goal. We can't cancel out the 4 yet because it's still in the parentheses. So I'm going to try and cancel this 2 out, and I notice that since it's in front of the parentheses, it means multiplying. All right, well, now again, I got to consider, well, what's the opposite of multiplying? Well, the opposite of multiplying is dividing. So in order to cancel out multiplying by 2, I'm going to have to divide this side by 2. And again, it makes it look like I'm doing something crazy, right? Oh, you tell me I have to divide that whole side by 2? Well, remember, all that's going to happen, just like the 8s previously, just like the 3s previously, is these 2's are just going to cancel each other out. It doesn't affect anything else on that side of the equation. So the x plus 4 is still going to remain a regular x plus 4. Okay? But now that there's nothing else on that side of the equation, the parentheses are no longer needed. So we'll get rid of those. But don't forget, though, that since we divided by 2 on the left side, we also have to divide by 2 on the right side. And this is where we actually do make the calculation. On the left side, it just canceled out. But on the right side, we actually have to simplify those numbers. So 120 divided by 2 ends up being 60. So we're going to say equals 60. And then we have only one step left, and that is to get rid of the 4. And since it's plus 4, the easy way to get rid of that is just to subtract 4. So we are going to subtract 4 on both sides, remember, because anything I do to the left side, I need to do to the right side. And so all that happens again is the plus 4 and the minus 4, just like the 8's up there, these are going to cancel each other out. And so now the only thing left on that side of the equation is x. And now let me just simplify what subtracting 4 does to the right side. So 60 minus 4 is just going to equal 56, right? So x is equal to 56. And that is our final answer. So I took my time with this problem. Honestly, when you guys have more practice with this, you guys will do this problem in less than a minute. So I obviously I took a lot longer, but I only took that much longer because I wanted to explain everything as thoroughly as I possibly could. Okay? But once you understand the process of doing things in reverse, then this will come a lot more natural to you. And you, like I said, you will be able to do it in less than a minute. So I don't want you looking at this going, oh my gosh, that looks like so much work. That's so hard. That's so confusing. Because at first, yeah, I can see how it'd be intimidating. But when you practice it, it really does become a lot easier. So don't worry about that too much. Don't be scared of it because it's really not that bad. And we will get better and better and better as we go on. Okay. So I'm going to close this out real quick and we will look at the solution that these guys have. Now they've solved it 2 different ways. The way that they have it on the right-hand side is the way that we did it. You can see to go from the first step to the second, they've removed the minus 8, and that's because they added 8 to the other side. Remember, 32 plus 8 made 40. And then they got rid of the 3 in the denominator, and they did that by multiplying by 3. So they've multiplied 40 by 3, and that became 120. And then they got rid of the 2, and they got rid of that by dividing by 2. So 120 divided by 2 became 60. And then, of course, they subtracted the 4 to get rid of the 4, and they ended up with 56. So it was kind of like a 4-step process. There is kind of a similar approach to it on the left-hand side, but that's probably a little less intuitive. That's probably a little bit more thinking to do method 1 way. I think method 2 way is very much, fluid, kind of easier to follow. All right. So you can see in their explanation down here in the bottom how they start with x and how this left-hand side is built. Basically, how do they create an equation like this? Well, you start with x, and then you added the 4, and then you multiplied it to the 2, and then you've divided all of it by 3, and then you took all of it and subtracted 8. So you can see how it's built on that process. And when we solve it, we are doing everything in the opposite direction. So the first thing we're getting rid of is the 8. Then the second thing we're getting rid of is the 3. Then the next thing we're getting rid of is that 2. And the last thing we're getting rid of is that 4. So that way we get x all by itself. So it's built like this, but when we solve it, we cancel things out in the backwards order to get that x solved for. Okay? All right, so let's try this problem. I won't spend every second trying to fully explain all the steps. Of course, I'll show you what the steps are. I'll tell you what to do there. But I'll make this problem go by a lot faster just for the sake of the fact that, in the long run, you can actually do these problems pretty quickly. So we have, I'm going to write the equation over here. We have 4 plus, then we got 3x minus 1 over 2 equals 9. All right. So we have to think about what we're going to get rid of first. Now, if you remember the order of operations backwards, is what we're looking for. We want anything being added or subtracted to the group. So the x, as you can see, the x is part of the second term. X is here, and it's a part of this fraction. So we can't touch that yet because remember, it's built that way. We have to undo it. We have to work from kind of the outside in, okay? So that shows us really that the 4 is our outsider, and the 4 is what we're adding to that expression, okay? So that 4 is positive, and it's being added to that expression, so we need to cancel out this 4. Now, since it's a positive 4, the thing that cancels out with a positive 4 would be subtracting 4, right? Because wouldn't 4 minus 4 become 0 and therefore cancel out? Yes, it would. So that's exactly what we're going to do. We're going to subtract 4 on the left. But since I subtracted on the left, don't forget we have to also do it on the right. So here on the left, the 4 minus 4 cancels out. That's going to just disappear, leaving us with 3x minus 1 over 2 equal to, don't forget to simplify here, 9 minus 4 is going to be 5. All right, the next thing I'm going to try and focus on is, since the x is on the numerator, I can't get to that part yet. Remember, I have to work my way from the outside in, try to break it, work this backwards. The next number I'm going to try and get rid of, and hopefully you're guessing it in your head, is this 2 in the denominator. That's the number I need to get rid of. And since it's in the denominator, it means dividing by 2. So currently, it's dividing by 2. Just like over here, it was adding 4. But remember, we have to, in order to solve, do the opposite of what's going on there. So since it's dividing by 2 and the opposite of that is multiplying by 2, I will multiply this side by 2 in order for that 2 to cancel out. But again, since I multiplied that side by 2, in order to cancel it out, I have to multiply the other side by 2 as well. So what does that show us? Well, it shows us that the 2's cancel out, leaving us just with the 3x minus 1. So again, we've gotten rid of the 4. We've gotten rid of this 2. Now don't forget to simplify the right-hand side. 5 times 2, that's going to change that number into 10. All right, so now what do I need to get rid of? Well, remember that x is a part of the term with 3x. So remember, we can't actually physically get to that until last, because remember, it's built that way, but we have to undo it from the outside in. So we can't deal with the 3x part first. So we're going to have to deal with this minus 1 part first. We're going to have to need to figure out a way to cancel that out. So the opposite of minus 1 now. If that's a minus 1, it will cancel out with a plus 1, right? Because minus 1, a negative 1, plus 1 means that will cancel out and become 0. So just don't forget, you need to add the 1 to the other side too. So with the 1 canceled out now, and the 1 being gone, or the minus 1 being gone, that leaves us with just the 3x equal 2. And on the other side, you're going to see 10 plus 1 makes 11. All right, so now the only thing left to get rid of in order to have the x by itself is that 3. The 3 is the last thing to get rid of. Now, what this currently says is this says 3 times x. All right, well, remember, you have to undo that. So the opposite of multiplying that x with a 3 would mean dividing by 3. So we will divide this side by 3 in order for the 3 to cancel out and therefore disappear. But that means I have to divide the other side by 3 as well. So by canceling out the 3's, now the only thing that's going to be left will be x. And on the other side, I have 11 divided by 3. So you can either leave it as that fraction, 11 divided by 3, or you can type it in the calculator and get the decimal version. So if you type 11 divided by 3 in, 11 divided by 3 is equal to, it's equal to 3.66 repeating. So you can write it in decimal form if you want. Either way, those are both the same number. So you can leave your answer as x equals 11 thirds, or you can write it as 3.66 repeating. So there's that question. So in here, I'm going to solve it. I'm going to write it in the fraction form. So I'm just going to go ahead and type in the fraction 11 over 3. 11 thirds, essentially. And that's what they wrote as well. They wrote it as the fraction 2. All right, so let's move on a little bit here. Let's try this next set of problems. So the sum of 3 consecutive integers is 132. What are the 3 integers? I love problems like this. They're really not hard, but they do require you to think. So here's what you need to remember. 3 consecutive integers. Oh, I need to screenshot this first before I can write on it. 3 consecutive integers. What that means is 3 numbers in a row, like 10, 11, 12, okay? Or 22, 23, 24, okay? 3 consecutive numbers, essentially. All right, so 3 consecutive numbers are added together to make 132. And honestly, a lot of you guys, if you spend enough time, could probably just guess what those numbers were. So, for example, I could just play around with my calculator a little bit. So I'm gonna for real, just showing you. I don't recommend this method because it's just a bunch of guessing and checking. But you could, in all honesty, just pick 3 numbers and see if you can get them to add up to, what was it again? 132? 132. So let's see. What if I tried to do like 42 plus 43 plus 44? What if I did those consecutive integers? I end up with 129, so I went too high, right? So maybe let's take it down a notch. What if I tried maybe 40 plus 41 plus 42? 123. Oh, wait, did I need 132 or 123? I think I might have miscounted there. What does it say? Oh, it says it wants 132. Okay, my bad. I thought I wanted 123 for a second. Okay, again, the wrong number. So maybe I do need to go the other direction. So let's try 43 plus 44 plus 45. So again, 3 consecutive numbers all added together, and those equal 132. So there, I've already known what my answer is. My answer is going to be 43, 44, and 45. Okay? But let me show you the proper way to solve this problem, because you will get much bigger numbers than this that will be much more complicated to solve. So how do we solve this without guessing and checking? Well, here's what we would do. We would call our first unknown number x. Now, again, I know that this number is going to be 43, but let's again pretend we didn't. The first unknown number would be x. And since the numbers are consecutive, the next number that I would add to it would be considered x plus 1, right? Because whatever x is, x plus 1 will be the number immediately after it. So, like, for example, if x is 43, then 43 plus 1 makes 44, right? And then to add the third consecutive number, I would call that one x plus 2. Okay, again, this is showing me that this is one number after my original, and this is saying the second number after my original. So essentially, consecutive numbers, right? And again, take x equaling 43, for example. So if x is 43, then the next number would be 43 plus 1, which is 44. And then 43 plus 2 makes the number after that. 43 plus 2 would be the 45. So this is how we would write three consecutive numbers. Three consecutive numbers. I would write it as x, because remember, the idea is I don't know what the numbers are. I only know these because I guessed and checked. But remember, you have to think about this problem. I'm going to show you how to solve this problem as if we didn't know. So if we didn't know, then we would call the first number x. We'd call the second number x plus 1, because it's one number after x. And I'd call this third number x plus 2, because it's two numbers after x. So this is how I would set it up. And since this one wants to equal 132, I would set this equal to 132. And from there, I will solve. Now, in order to do this, I'm going to combine all my x terms. So I have 1x plus 1x plus another x. So when I combine this, that means I have 3 x's. So I'm going to combine those all to make 3x. And as far as the regular numbers go, I have a plus 1 and a plus 2. And if I'm adding 1 and I'm adding 2, 1 plus 2 makes 3. So that would combine together to be plus 3. So I just simplified that. So the x plus 1 plus x plus 2, I simply combined the like terms in order to get 3x plus 3. And that's, remember, still equal to 132. So I didn't cancel anything out. All I did was combine pieces together. I combined all these x's together into 1. And then I combined the numbers together into 1. That way I only had one term of an x and then one term with a number. And so from here, I do need to solve. So in order to solve this and get x by itself, the first thing I need to try and cancel is going to be this plus 3. I need to get rid of this. I need to cancel that out. So what's the opposite of plus 3? The opposite of plus 3 is subtracting 3. So I will subtract 3 in order to cancel it out. But just remember, you have to do that to the other side too. So when I cancel out the 3, when that's gone, then all I'll have is just the 3x on the left side. And on the right side, I have to simplify. 132 minus 3 is 129. So now I just need to, in order to cancel out this last 3, this 3, remember, it's 3 times x. So right now it's multiplied. So to undo that, to do the opposite of that, I will have to divide by 3 in order to get those to cancel out. So that means dividing the other side by 3 as well. And when I do that, when I cancel those 3's out and I just have x by itself, and I simplify the 129 divided by 3, 129 divided by 3 becomes 43. Okay, and you can take the calculator just to double check, right? 129 divided by 3 is equal to 43. So what that tells me is my answer. This tells me that x is 43, means that my first number is 43. So in order to write 3 consecutive numbers, the next 2 following it would be the 44 and the 45. So I'm solving, when I solve for x, I'm finding the first number out of my 3 consecutive numbers. And of course, if I know the first number is 43, then I know the next 2 would be 44 and 45. All right, let's do another one, because I know that it's definitely, when it's new to you, it's new to you. And I understand how that feels. So I think the best way to learn something like this is going to be just through practice. So here's exactly the problem we just did. So you can see it's worked out exactly the same way as we worked it out. Let's try a different example. So let's set up the same thing. 3 consecutive odd integers is 57. Okay, this is a little different. okay? Because we have to pay attention to the words carefully. We're doing 3 consecutive odd integers. So it's not 3 consecutive integers, not 3 consecutive numbers, but instead 3 consecutive odd numbers. So for example, that would be numbers like 5, 7, and 9, right? 3 consecutive odd numbers. So there's no evens here. Another example would be, 11, 13, and 15. These are 3 consecutive odd numbers, okay? So again, if you want, we can try the guess and check strategy real quick. We can always give that a go. So let me pick 3 consecutive odd numbers that I think could add up to 57. So let me pick let's try 15 as the first one. So then the next one would be 17. And the one after that would be 19. So that gets me the number 51. That's not what I needed. I needed to get to 57. So let me try some bigger numbers. Let's try 19 as the first one. So then the next two would be 21 and 23. That's 63, so that was too high. So I should try it again. So I guess it should probably be 17, might be the first one, plus the next odd, which would be 19, and then the next odd after that would be 21. And I get 57. So I guessed and checked, and I just played around with a couple different options until I got the right answer, right? 17, 19, and 21 will be the answer. But again, let me show you how to do this through algebra, because remember, they won't always be something that's easy to guess and check on. Sometimes it's a lot harder to guess and check. These are just simple examples, so guessing and checking works, but like I said, you need to know how to do it the proper way, because you're going to run into problems that are much harder than this, or at least the numbers are bigger. I won't say it's harder because it's the same thing, but the numbers might be a lot bigger, so it's going to be more challenging to guess the numbers correctly. All right, so how do we get these answers? So 3 consecutive odd numbers. So again, pretend we don't know what the first number is, so we'll call it x. And so when I add another number to x, the next number, if it's an odd number, notice how an odd number, the next consecutive odd number is two numbers bigger than the previous one. So if this number was like 17, for example, then the next odd number would be x plus 2, right? In order to skip the even number, instead of adding 1, I'd have to add 2 in order to jump from one odd number to the next, right? Because all the odd numbers appear 2 at a time, right? 17, then 19, then 21. All right, so I'll have to put the next number as x plus 2. And then the last number would have to then be x plus 4. This number is going to be 4 more than the first one. And the 19, for example, the second number is going to be 2 more than the first one. So it's very similar in how we set it up to the last problem. But because it's odd numbers, and odd numbers occur every 2 numbers, that's why we're increasing by 2 each time. So adding 2 to this one, and then adding an extra 2, right? 4 altogether, to get the third number. And so we just go from here and we solve. So remember, this is equal to 57. And we start by solving by combining like terms. So I have an x, and an x, and an x. 1x, 1x, and 1x. If I combine all 3 of them together, that makes 3x's. Same thing with the regular numbers. If I have the plus 2, I have a 2 here and a 4 here. If I combine that, 2 and 4 together makes 6, right? Because 2 plus 4 makes 6, so that would be plus 6 equal to 57. And from there, we just solve. So just like before, we'll cancel out the plus 6 by subtracting 6, right? Positive 6 minus 6 cancels out. So don't forget to do it on the other side, though. So if we cancel out the 6's, then the only thing there is going to be 3x. 3x is going to equal, let's simplify here, 57 minus 6 is 51. And then lastly, keep in mind the 3 and the x being multiplied together, so we have to undo that. Opposite of multiplying by 3 is dividing by 3, so we'll divide. These 3's on the left are then going to cancel out, so the only thing on the left is going to remain x. And then 51 divided by 3 will give us our answer. So we would take a calculator we would do 51 divided by 3. And we end up with 17. So that tells us that the first odd number would be 17. So 17 is the first odd number, then the one after that would be 19, and the one after that would be 21, just as we said in the guess and check answer that we made earlier, right? But this is the process in which you would go about solving it. So I would type in 17, 19, and 21. All right, let's try this example 3, and I think we'll end the video after example 3, and we'll pick up another video to continue lesson 2 after we go through these next 2 problems. So a lab technician needs 25 liters of a solution that is 15% acid for a certain experiment, but she has only a solution that is 10% acid and a solution that is 30% acid. How many liters of the 10% and the 30% solutions should she mix to get what she needs? All right. So she needs 25 liters altogether. She has one with a 15% acid and one with a 10%. Hold on. She needs 25 liters, that is 15%. She currently has a solution that's 10% and one that's 30%. How much of each type does she need to mix together in order to get 25 liters of 15% acid? So let's walk you through this one. So in order to write an equation relating the liters of acid in each solution, represent the total number of liters of one solution with a variable like x. Then the total number of liters of the solution must be 25 minus x. So here's our goal, right? 25 liters of a 15% solution. So 25 times 0.15. Now 15%, remember, as a decimal. 15% as a decimal is 0.15. Think of it like a penny. It's like change. If you have 15%, 15 cents, then it would look as a decimal as 0.15, right? As 15 cents. All right, and then of course times 25, which is 3.75. So that's our goal. That's our target amount. So if we don't know how many liters, so that's why we call it x. X amount of liters of the 10% solution. That's going to be the 10% being 0.10, or again 0.10. To say 10 cents, 10%, 0.10x, plus the 25 minus x, which is the leftover amount, times the 30% solution. Okay. So 30% times whatever the leftover amount is. And so we get the 0.30 times the 25 minus x. And so this is distributed. 0.30 times 25 becomes 7.5. And the 0.30 times the minus x becomes a minus 0.30x, or minus 0.3x. And so from here, you just combine your like terms and you solve the problem. So here you would combine the x terms. So 0.1, oops. Here. This never works. The 0.1x minus the 0.03x will become negative 0.2x. Let me see if it'll show up. Yep, it shows up there as a negative 0.2x. And if you move the 7.5 to the other side, you would subtract it. So you would subtract 0.75. So 3.75 minus 7.5 ends up to negative 3.75. And from there, you just divide by the negative 0.2, and you end up ultimately with 18.75 as your x, as your number of liters per solution. This is not the easiest question, and I understand that. I don't think I've ever seen a question as complicated as this so early on in algebra. But I do want you to see it just so that you've gotten some exposure to it. We will talk a lot more about problems like this in the future. It's definitely a step above what we were doing before. So let's see, is there anything else I can cover in this video? I think I'll save the rest for this part 2 of this, which I guess is something we'll probably cover on Monday. Everything I've done in this video is probably something we covered on Friday, the 28th, and what I do in the next video will be what we cover on Monday, the 31st. So, I hope you learned something. Hope you took something away from this. Hope you got some good notes. Hope this helps with your homework problems, whatever the case may be. I will see you guys in the next video. All right. Bye for now.